Number 100. Show very low resistance if it is in a series field coil. Show very low resistance if it is a series field coil. So when using an ohm meter to check the continuity of a generator field coil, the coil should show very little resistance if it is a series field coil. Show very low resistance if it is a series field coil. All right? When using an ohm meter to check the continuity of a generator field coil, the coil should show very little resistance if it is in a series field coil. Number 101. The number of turns of wire in the coil and the amount of current, which are the amps passing through the coil. So the number of turns of a wire in the coil and the amount of current, amps, passing through the coil. That makes more sense. So the strength of the core of the electromagnet depends upon the material from which it is constructed and which of the following: the amount of turns in the wire in the coil and the amount of current that's passing through the coil. So if you think about that, electromagnets, have you ever guys made a magnet? So do this real quick, right? So you take just copper wire, right? You take copper wire, and you put it onto, I don't know, let's say two nails. Okay, you take a nail, and then you put copper wire, and then you put copper wire, and you make the coils, and then you put it on it. So you have two nails, copper wires, right? All right. So now what you do is also you put that to a power source, whether it be a 9-volt battery, a 12-volt battery, whatever it is. You put that there and make sure that the copper wiring can hold it. So once you do that, you just created a magnet. All right, you just created an electromagnet. So the strength of the core of the electromagnet depends on the material from which it is constructed of the following. So it depends on how strong, right, the copper wiring is, how many turns of the coil, and the amount of current. So it depends on also how much voltage you're running through. All right, so there you go. I know it's got nothing to do with aviation, but it's got something. It's fun. Strength of the core of the electromagnet depends upon the material from which it is constructed of which of the following: the number of turns of the wire in the coil and the amount of current passing through the coil. There you go. Okay. Number 102. Resistance of the generator field circuit. Resistance of the generator field circuit. Resistance of the generator field circuit. So a voltage regulator controls generator voltage by charging the resistance of the generator field circuit. The voltage regulator controls generator voltage by changing the resistance of the generator field circuits. Voltage regulator controls generator voltage by changing the resistance of the generator field circuits. Number 103, opening the shunt field circuit. Opening the shunt field circuit. So the overvoltage control automatically protects the generator system when excessive voltage is present by opening the shunt field circuit. So the overvoltage control automatically protects the generator system when excessive voltage is present by opening the shunt field circuit. Opening the shunt field circuit. Number 104. So increasing the output in the low generator and decreasing the output of the high generator until they are equal. Sounds like a paralleling to me. Increase the output of the low generator and decreasing the output of the high generator until they are equal. That's exactly what it is. So when DC generators are operated in parallel to supply power for a single load, their controls include an equalizer circuit to ensure that all generators share the load equally. The equalizer circuit operates by increasing the output of the low generator and decreasing the output of the high generator until they are both equal. All right, that's something you guys are going to have to do all the time, is paralleling DC generators. All right, like when you change a DC generator, you have to, yeah, it's fun. So, okay, back to it. All right, so on this one, increasing the output of the low generator and decreasing the output of the high generator until they are equal. Until they are equal. Number 105. So it's 2 minutes. What is the maximum time a circuit can be in operation and still be intermittent duty circuit? What is the maximum time a circuit can be in operation and still be an intermittent duty circuit? It's 2 minutes. 2 minutes is the maximum amount of time. 2 minutes. Number 106. Current flowing through the shunt field coils. Again, the shunt field coils. Current flowing through the shunt field coils. So the most common method of regulating the voltage output of a compound DC generator is to vary the current flowing through the shunt field coils. Current flowing through the shunt field coils. So the most common method of regulating the voltage output of a compound DC generator is to vary the current flowing through the shunt field coils. Number 107. So it looks like we have a figure here, and referring to figure 18, which of these batteries are connected together incorrectly? Incorrectly. Well, it's telling you that the third one is, but let's figure out real quick why. All right, so the first one, you can see that it's connected in positive, negative, positive, negative, positive, negative. That looks like it's connected in series. All right, seems like it's correct, right? The positive, the first one in positive goes straight over to its source, and then the negative goes straight over. That's connected in series. That seems correct. Let's go to the number 2. You have a positive, 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 negative, negative, negative. That is corrected in parallel. Everything seems to be okay. So let's look at the third one. You have a positive, negative, positive, and it's corrected in parallel. That is wrong. You can't do that. So that's the answer right there. If the batteries are connected together incorrectly, it's definitely number 3. Okay? There you go. Definitely number 3. All right, so number 108, short in the up limit switch. So we have another figure here, and there's a short in the up limit switch, right? So let's look at figure 19, and it says, upon completion of the landing gear extension cycle, the green light illuminated and the red light remained lit. What is the most probable cause? So referring to figure 19, go ahead and pull it out if you want, and just know that there is a short in the up limit switch. There is a short in the up limit switch. All right? There is going to be a short in the up limit switch. So if you look right here, up limit switch, there is a short. All right? There's going to be a short in the up limit switch. All right? So upon completion of the landing gear extension cycle, the green light illuminated and the red light remained lit. What is the most probable cause? Well, if everything is here, and you know that if the up limit switch gives you the lights, there's going to be a short. Just figure 19, there's going to be a short. All right? Figure 19, it's going to be a short in the up limit switch. Number 109. An out of adjustment voltage regulator, an out of adjustment voltage regulator, an out of adjustment voltage regulator. So if any one generator in a 24 volt DC system shows low voltage, the most likely cause is an out of adjustment voltage regulator, an out of adjustment voltage regulator. If any one generator in a 24 volt DC system shows low voltage, the most likely cause is an out of adjustment voltage regulator, an out of adjustment voltage regulator. Number 110, Reverse the electrical connections to either the field or armature windings. Reverse the electrical connections to either the field or armature windings. So how can the direction of a rotation of a DC electrical motor be changed? You reverse the electrical connection on either the field or the armature windings. You reverse the electrical connections to either the field or armature windings.